My name is Amber. I am a second-year graduate student here at the University of Minnesota Duluth. I am working with Dr. Nathan Johnson. Our project is trying to figure out why the mercury in the fish is so high in the St. Louis River Estuary. There has been some work done by other scientists in the area at the EPA and at the MPCA who have demonstrated that the fish who eat in the estuary have more mercury in them than the fish that eat in Lake Superior or fish that eat in upstream of the estuary, so further up in the St. Louis River. So there's two relevant kinds of mercury that we're talking about here. One kind of mercury is inorganic mercury, and that's the mercury that you would find in thermometers. This kind of mercury isn't abundantly harmful to people, which is why your parents or grandparents have stories of themselves playing with the liquid mercury out of broken thermometers. The other kind of mercury is methylmercury, and this means that mercury has changed from the inorganic form to an organic form. And when it has turned into this organic form, it has a different shape and a different structure, which models some proteins or amino acids and makes it much easier to pass through membranes and stomach linings, for example, which is why methylmercury can bioaccumulate much faster and is much more of a significant risk for bioaccumulation than inorganic mercury. We know that methylmercury can accumulate in humans' bodies over time. What that means is that because the mercury doesn't leave your system as readily as other things leave your system, that when we're measuring how much mercury is in fish, we need to consider the long-term effects of the total amount of mercury that someone may have eaten. So when you measure mercury in fish, you're actually looking at what's called a chronic standard, which means the standard accounts for the most amount of mercury you can eat either every day or every week or every month before you hit a level of mercury that's actually toxic to you. So even though you may go out and eat fish that has mercury in it and you feel fine the next day, that mercury may stay in your system for a long enough time that in 30 or 40 years you may start to feel the effects of that. When we go out and conduct our research, we collect both sediment and water samples. The first kind of water sample we collect is called a surface water sample, which is essentially the water that you swim in and the water that we take to get our drinking water from. We also measure pore water, which is the water in the mud in the bottom of the river. Pore water is what makes the bottom of rivers mushy as opposed to solid ground on soil. We also measure mercury in the sediment, and when we do that, we can break it down into either one large section of maybe the top 4 centimeters of sediment, or we can break it down into smaller sections of either 1 centimeter thick sections or 2 centimeter thick sections to look at a depth gradient going into the sediment. This is relevant because there's a small zone of which metals or anything can pass from the sediment into the water column, because if it's deep enough in the sediment, it's not going to be relevant and released into the water column. We haven't finished our project yet and still have a year left to go on our grants, but we've definitely noticed some seasonal variations in the amount of mercury in the water that has to do with runoff coming from upstream in the St. Louis River or the temperature, because there are bacteria that methylate mercury, and so if the temperature is not warm enough, then they won't be methylating mercury. I think it would be really great if our research could help reduce the amount of mercury in fish and reduce the restrictive fish consumption advisories. Currently, the St. Louis River Estuary is listed on the Minnesota Pollution Control Agency's 303D list of impaired waters. So that means that the water quality is not as high as it could be. It's not as high as it could be because of the mercury in the fish. However, it would be really nice if the work that we're doing can help remove the mercury problem from the St. Louis River Estuary. Environmental systems tend to change very slowly and take a lot of time to respond to the work that you do to them, and don't always respond on the time scale that humans think they will respond. So the work that we're doing now may have significant impacts down the line, even when we're not here.